Okay, so one thing they like to do a lot in HSC questions is have like these cross-topic ideas. So incorporating different topics across the board. And here's an example. We've got our little frequency table over here, and it's got some classes as well. So we've got these intervals, and they are the retirement ages of 2 million people displayed in the table. Man, there are people retiring at 36. That is pretty crazy. This is in number of thousands of people as well, so just keep that in mind. Not just 5 people, because if we had 2 million in the data, I think 5 would be a very small amount. So what is the relative frequency of 51 to 55 year retirement age? So this idea of a relative frequency, remember, it's kind of like asking the experimental probability. It's saying, okay, well, there's a theoretical chance of something happening, but when we collected the data, this is what happened. And so this is exactly what's going on here. I want to go to the 51 to 55 age bracket, and I can see that there are 35,000 people in this age. So the relative frequency, so part 1, the relative frequency is going to be how many people were in that group, so 35,000, divided by all the total people, which was 2 million. Okay, and I'm going to get a decimal for that one, so 35,123 over 2 million, 1, 2, 3, 2, 3. I get 7 over 400, or if you'd like, you can write that as a decimal. Well, not very many, is it? It's 1.75%. Now, when we talk about distributions, remember the way that I said we want to think about it is when you compare your number line, there are two sides. There's a negative and there's a positive, right? A negative and a positive. And if the tail end is towards one side or the other, that's the direction which is skewed. So if the tail looks like this, then that's negatively skewed. If I had another one over here, let's do a different color. Let's use, like the rainbow color. So negative and positive. If it was like this, that would be positively skewed because the tail is to the positive side. So the question is, what's this here? And this is in a frequency table, so it's a bit hard to read, but what I'm going to do is I'm going to get a bit creative here, and I'm going to, if I can actually do it, I'm going to rotate this. I'm going to try to rotate this. Okay, there we go. So I've rotated it left. And when you look at it, now you can more clearly see which ones are the ones to the negative side, which ones are the positive side, right? Because the positive side is where the numbers are getting larger and larger. It's not necessarily that the numbers are positive or negative. So it's getting larger and larger here. This is the positive side. And then when you start going towards the left, that's the negative side because the numbers are getting smaller and smaller and smaller. So that's how I'm going to determine my distribution. And where are the numbers weighted more? Well, as you can see, there's a lot in the 61 to 65, 66 to 70 bracket. So over here, there's quite a bit of a tail end. There's a lot less people retiring at a younger age, which makes sense. So when I do that, I can see that it's negatively skewed over here. So part 2, it is negatively skewed. I want to make a note about this particular situation. As the age increases, so does the number of retirees. Another thing they like to do is they like to start introducing comparisons between data sets. So not just looking at one of them, but comparing 2 sets, okay? And in this one, we've got a back-to-back stem and leaf plot. So the way it's constructed is the stems are down the middle, and then which are shared, and then the leaves are on either side. So you've got men and women, and it looks like it's a dance class. I probably should attend those because I cannot dance. So Pat claims that the women who attend the dance class are generally older than the men. Is Pat correct? Justify your answer by referring to the median and skewness of the 2 sets of data. So the stuff I've highlighted, notice how this is worth 3 marks here. And a rule of thumb is, I guess you're looking really for a few different things that you can talk about. It's not enough to just say, yes, he's correct, right? That's not really enough. We have to justify our answer. And there's 2 things that they've asked us to refer to, the median and skewness of the 2 sets of data. So that gives you an idea of where these 3 marks are going to come from, right? And if I want to look at this, let's work out the median first. So the median, remember, is the middle value, and it depends on how many values that we have here. So for the men, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Now to find the median, you could just count in from both ends, or you can use the n+1 on 2 trick, which tells me the position instantly. So for the men, I've got 9 plus 1 on 2, which is just 5. So I'm looking for the fifth number. So 1, 2, 3, 4, 5. And remember, a stem and leaf plot, this is like your first digit here. That's your second digit. So the median is 45. Okay, let's do it for the women as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 plus 1 on 2, that's going to give me the position, which is 7. So 1, 2, 3, 4, 5, 6. Oh, and be careful when you're counting. It does have to be from, I guess, ascending order or descending order. So if you're counting from the top, then you need to count 1, 2, 3. And then these ones are smaller here, right, on closer to the stem. 4, 5, 6, 7. And that looks like it's 55. So the median here is 55. Okay, so initially we can already see that the median is high for the women. That checks out. What I do want to check though is the skewness. And with the skewness, I want to do the same thing as I did before. It's not necessarily easy to see what the skewness is without rotating it. And I can't rotate, unfortunately, on my iPad because it's just going to rotate the screen and it won't work properly. But what I'll try and do is I'll try and paste it and then rotate it. Let's see if that works. Okay, so here's what I'm going to do. I'm going to try and rotate this. I want to compare my distributions now, right, in terms of their skewness. So remember, the larger values, that's where the positive... Okay, so now I want to compare the distributions in terms of their skewness. So remember, the larger values, that's where the positive side is, and the smaller values, which are heading towards 0, or the negative values, that's where we say our negative side is. And so this is why I tend to remember it in that way, rather than remembering it as left or right, because you notice what's happened here when I've turned my page around for this women's side of the stem and leaf plot, is that now the sides are kind of swapped, right? So the larger values are on the left-hand side and the smaller values are going towards the right-hand side. This is why I tend to avoid remembering left and right, because for a situation like this, you'll make a mistake in terms of the skewness. So now when I've constructed this out, I can see there's a much higher frequency here. And so this one, the men, that's going to be positively skewed. That's where the tail is. And for the women, if I try and trace out this distribution as well, it looks the same, but remember, because of how I've rotated it, the women, this tail is on the negative side over here, like the smaller points over here. So that's going to be negatively skewed. What negatively skewed means in this situation, if there's a tail end towards the smaller values, right, that means there's less people in these younger ages, whereas when we look at the men, it's positively skewed. So there's less people in the older ages. So remember, what's the original claim? The original claim was that the people who attend the dance classes are generally older than the men. And so this looks to be true. So we just want to make a brief statement about this. Pat is correct. We should explain why. Since the median age for women is higher and its distribution is negatively skewed, meaning that there are less younger women and more older women. Okay, so just a brief statement about each of those and justification as well.